So how do we find the shortest distance between two skew lines or parallel lines, I guess? Of course, if lines intersect, the shortest distance between them is just 0. So two skew lines, if you're at this, you'll probably be just given two lines and told they're skew, but you might have to check it out. I'm not entirely sure. But anyway, for the purpose of this, we'll assume you're just given they're skew. The shortest distance is equal to the distance of the perpendicular line between them. And this makes sense. Okay, but for the sake of argument, let's draw a couple of lines. Hard to draw skew lines in a two-dimensional space, but anyway, this one's going under this one. The shortest distance will be where this line is a right angle to both lines. Okay? Alright, so how do we do this? Well, we know this is L1, L2, and line 1 has vector equation. We'll just say A1 plus lambda D1, A2 plus lambda D2, A3 plus lambda D3, R2, and this is quite a long method, so I'm conscious to not make this video too long, so I won't be running through an explicit example. I'm going to be giving you the general method that you can use to solve these. B3 plus mu C3, and what we want to do is what we know, we want to find the distance of this line here that runs perpendicular to both the lines. So what would that line be? The line would take the form R2 minus R1, but for specific values of mu and lambda, that line's only going to be perpendicular at 1 point on R1 and 1 point on R2. So that's what we're aiming to find. So we subtract these lines, okay, and you just subtract in the normal vector way. Then how do we find perpendicular lines? Well, we use dot product. So we take R2 minus R1. Bear in mind this is a line itself. And we'll dot that with R1. And that should be 0. We can use that to find lambda in terms of mu, or mu in terms of lambda. Rearranging that equation. And then we'll take R2 minus R1 and dot that with R2 and set that equal to 0. Okay, now we can use that to find mu and lambda, such that we've got this perpendicular form. Now we'd substitute mu and lambda back into here to find specific points R1 and R2. So these points could say be x1, x2, x3, and y1, y2, y3. Now we've found those points on the line. We just have to find the distance between these 2 points, okay? Because we found the 2 points on the line that are closest to each other, and the distance would be the square root of y1 minus x1 squared plus y2 minus x2 squared plus y3 minus x3 squared, all square rooted, and that would be our answer. Okay, I found, I've seen students do a step there. Generally, typically, if they remember the method, they tend to be able to do this. It's the computations are particularly difficult, but what I would say is make sure you practice questions on this, because it's often worth 6 or 7 marks, even, especially if they add some sort of extra context on it. It'll be worth 9 or 10, and that is a hell of a lot of marks on your paper. So this is a very, very important topic. So I'll definitely cover if in the future I go on to live stream, which I'm looking to get set up, where you guys can ask your questions, but I'll answer them. No one's got any specific questions. I'll just run through some important examples. So probably find stuff like this there because it's a longer form, and it's the type of thing that if you run through an example, you want people to be able to respond. So I didn't get that bit here, and you can run back over it in a slightly different way because it can get a bit weird. For now, that's it. Thanks for watching.